Good day to everyone. In this video, I would like to demonstrate how robust options work. And I go through several softwares. You can find the same options in another Zond products and use it when you wish. So I will start with 1D software for time domain electromagnetic. So here is important options to do a robust inversion. And these options, this workflow deal with smoothness type. It's still here norm, but we will rename it future. This is actually smoothness type, and you should use L0 type, which means piecewise models. So another options you can find here. I really recommend reference model M0 as median model. And here is the options, robust model, you should choose it. And it's also controlled with parameter threshold. And approximately 0.01 will be optimal for most cases, but you can play with it. So let's compare regular smoothness constraint inversion with robust. So typically we can see that our model is pretty smooth. And to fit it better, we should use smaller smoothing parameter. Let's back to original. So you can see here this very typical view of model for such inversions. Okay, now we're back to our smoothing factor and choose robust. Now you can see very simple structure, and RMS error is much better in this case, and only 6 layers in this model. So it looks okay. It's work for both for resistivity and for thicknesses of layer. So also these options influence to another type of inversion. For example, we have pseudo 2D inversion. It doesn't mean any 2D, only smoothing operator flatness matrix. Okay, now we can try to do such inversion. It's a little longer because it's involved all soundings together in inversion, but we may check just maybe 2-3 first iterations. Well, if you have a very dense, but maybe not very dense survey of time domain electromagnetic, this kind of inversion works pretty good, because I suppose it's maybe better than standard LCI inversion, because it's not continued all our 2D or 3D targets, and it can have a contrast boundaries. This is what differs pseudo 2D inversion from another style of inversion based on 1D or So this is how it looks like. We wouldn't wait till finish, so I'll stop. Okay, next one is electrical tomography. And here is the same options in smoothness type, also median model, robust. And here is a smoothing factor and threshold. So how model will looks like depends on threshold, on combination, smoothing factor and threshold. And we will try to start without robust inversion. Let's check. No robust. And see how the model looks like. Yes, it's very smooth boundaries. There is no changings because it's very high smoothing factor selected. So RMS a little bigger than in case of robust inversion. And the next one we will check it with, let's compare it visually. Okay. And now I will choose robust inversion. Oh, sorry. I would start with half space again. So this has a very blocky structure, final model. So degree of blockage depends on threshold and smoothness factor. So you can control it and resolve for different models. Now you see it's like one block, another block, another. What for visualization of such model, I recommend special settings, which intended in software. First of all, with a standard contour section, but we can make it a little different. With options of smoothing contours and these options blocky contours. Now it looks very similar to blocks model, but in contours. This is, I think, perfect type of inversion for synthetic data inversion, because we used to testing use this kind of model like 2-3 blocks in horizontally layered model, but it also works good for the field data. Sometimes depend on type of challenge. If they have a contrast piecewise challenge, it will work good. Okay, and even in seismic, we can do the same. Here is the same options. Of course, it's work not that good like in resistivity methods, but here we can also resolve for piecewise model. Let's see the same options, robust, and here is threshold and smoothing factor, which control all. Let's try not robust inversion. So this model with smooth boundaries. And the next we can try this robust. Okay. Now you can see that RMS lesser and model has a blocky structure. Of course, it's maybe not so good, but as I said, you should play with this parameter or combination of these two parameters. Let's see what I can changing. So it's a little less blocky now. And you can see that border is very contrast. And the same settings here. If you don't want to have such step style of boundaries, you need to choose diagonal smoothing option. This is diagonal filter. And I forgot to show you comparison of two models. This is very different. This is another reason, especially for ERT, to show that we couldn't compare different softwares or even algorithms, even one settings of algorithm like a smoothing factor give absolutely different model in the deeper part. They always has the same, practically the same in the upper part of model where the sensitivity is very high, but here in the lower part it's maybe completely different. And here is Bluetooth stuff can be applied. So thank you very much and see you soon.